4.5 billion years ago, in the swirling dust disk of the nascent solar system, planet Earth was born. From a toxic, molten hellscape of liquid magma to a vibrant blue marble teeming with complex life, our home planet has undergone staggering transformations. Yet Earth's story is only half written. As our Sun ages and expands over the next 5 billion years, Earth will experience equally dramatic future eras. Backed by peer-reviewed geological data from NASA, USGS, and the International Commission on Stratigraphy, we explore Earth's full planetary life cycle. We will examine our world at every single 1 billion year mark, from minus 4.5 billion years in the past to plus 5 billion years in the far future. Witness the birth of oceans, the rise of atmospheric oxygen, supercontinent mergers, ocean evaporation, and Earth's ultimate solar engulfment. Welcome to Earth at every billion-year mark, past, present, and far future. Minus 4.5 billion years ago, the Hadean Aeon and the birth of Earth. Gravity pulls planetesimals and asteroid debris together, accreting into a violent, glowing protoplanet orbiting the young Sun. Surface temperatures exceed 2000 degrees Celsius, Earth possesses no solid ground, only a churning ocean of liquid rock and molten magma. Around 4.51 billion years ago, a Mars-sized protoplanet named Theia collides with Earth in a catastrophic impact. Vast plumes of vaporized rock are blasted into orbit, rapidly coalescing to form Earth's massive companion, the Moon. The toxic early atmosphere consists of carbon dioxide, methane, water vapor, and nitrogen, completely devoid of free oxygen. As the planet slowly cools over tens of millions of years, the first solid basaltic crust begins to solidify, recorded in ancient zircon crystals. Torrential rains fall uninterrupted for centuries as atmospheric water vapor condenses onto the cooling surface. By 4.4 billion years ago, the first liquid water oceans cover the planet, hot, acidic, and rich in dissolved iron. Era 1 Summary: the Hadean Earth was a molten volcanic world laying the liquid foundations for life. Minus 3.5 billion years ago, the Archean Aeon and the dawn of biological life. Earth is an alien ocean world. High concentrations of dissolved ferrous iron give the oceans a deep green hue. The skies are a smoggy orange tint, filled with atmospheric methane produced by early volcanic outgassing. The young Sun shines 30% dimmer than today, a phenomenon known as the faint young Sun paradox. Deep beneath the waves, around mineral-rich hydrothermal vents, chemical reactions spark the last universal common ancestor, or LUCA. In shallow coastal waters, microscopic cyanobacteria form dome-shaped microbial reefs called stromatolites. These humble microbes invent oxygenic photosynthesis, absorbing solar energy and releasing tiny bubbles of free oxygen. Initially, released oxygen reacts with dissolved oceanic iron, precipitating vast red rust layers onto the seabed known as banded iron formations. Volcanic island arcs collide to form the first small continental cores, known as cratons, building the seeds of future landmasses. Era 2 Summary: the Archean Aeon birthed single-celled microbial life beneath green iron seas. Minus 2.5 billion years ago, the Great Oxidation Event and Snowball Earth. As oceanic iron sinks become saturated, oxygen overflows into the atmosphere, triggering the Great Oxidation Event. Atmospheric oxygen reacts with greenhouse methane, converting it to carbon dioxide and severely weakening Earth's insulation. Global temperatures plunging Earth into the Huronian glaciation, the first snowball Earth episode, lasting 300 million years. Glaciers over 1 kilometer thick cover the entire planet, freezing the oceans from poles to the equator. Life survives trapped beneath thick ice sheets around volcanic hydrothermal vents and thermal hot springs. Centuries of volcanic carbon dioxide emissions gradually build up in the atmosphere, triggering a massive runaway greenhouse thaw. High in the stratosphere, solar ultraviolet light splits oxygen molecules to form the protective ozone layer, shielding land from lethal radiation. Surviving single-celled organisms evolved complex internal structures, forming the first eukaryotic cells with defined nuclei. Era 3 Summary: The Great Oxidation Event transformed Earth's atmosphere and created complex eukaryotic life. Minus 1.5 billion years ago, the boring billion and supercontinent cycles. Geologists designate the Middle Proterozoic as the boring billion due to remarkably stable climate, oceanic chemistry, and tectonic pacing. Continental landmasses drift together to assemble ancient supercontinents like Columbia and later Rodinia. The land remains completely barren and lifeless, devoid of plants, trees, or animals, resembling red Martian desert cratons. In the oceans, red algae pioneer sexual reproduction, accelerating genetic diversity and multicellular evolution. Around 700 million years ago, the breakup of Rodinia triggers another global snowball Earth, the cryogenian glaciation. Following the thaw, oxygen levels surge, triggering the Ediacaran biota and the Cambrian explosion 540 million years ago. Life diversifies rapidly: marine invertebrates, armored trilobites, giant sea scorpions, and early jawless fish fill the oceans. Plants and insects colonize land, followed by amphibians, reptiles, dinosaurs, and mammals on the supercontinent Pangaea. Era 4 Summary: The Middle Proterozoic set the evolutionary stage for the explosion of complex terrestrial life. Present day, 0 years the Anthropocene blue marble. 7 continents are dispersed across a vibrant ocean world, balanced by polar ice caps and lush tropical biomes. Atmospheric composition stands at 21% oxygen and 78% nitrogen, an ideal equilibrium for complex aerobic life. Over 8 billion humans inhabit the globe, constructing megacities, global digital networks, and space telescopes. Earth orbits safely inside the circumstellar habitable Goldilocks zone, where liquid water covers 71% of the surface. Human civilization reshapes planetary geology, climate dynamics, and biodiversity in a new epoch called the Anthropocene. Satellites and space probes look back from orbit, photographing the shining blue jewel in the cosmic dark. Era 5 Summary: Present-day Earth represents the peak zenith of biological diversity and technological civilization. Plus 1 billion years in the future, the moist greenhouse and ocean evaporation. As the sun burns hydrogen fuel in its core, solar luminosity increases by 10%, raising global temperatures dramatically. Increased solar heat triggers a moist greenhouse effect. Oceans begin evaporating at an alarming rate into the upper atmosphere. Rapid weathering depletes atmospheric carbon dioxide below 10 parts per million, causing plant life and forests to go extinct. Without plants producing oxygen and herbivores dying out, animal life perishes, leaving Earth a scorched, arid desert world. Era 6 Summary: At plus 1 billion years, rising solar heat evaporates the oceans and extinguishes complex surface life. Plus 2.5 billion years in the future, total desiccation and liquid core freeze. Solar ultraviolet radiation breaks atmospheric water vapor into hydrogen and oxygen, lighter hydrogen gas permanently escapes into space. Every drop of liquid ocean water has vanished. Earth is a completely dry, salt-crusted desert planet resembling modern Venus. Earth's liquid outer core cools and solidifies, halting dynamo rotation and destroying the protective planetary magnetic field. Unfiltered solar wind strips away the remaining atmosphere. The last subterranean extremophile microbes go extinct. Era 7 Summary: At plus 2.5 billion years, Earth is a completely sterile, magnetless desert world. Plus 5 billion years in the future, the red giant sun and Earth's final engulfment. The sun exhausts core hydrogen, expanding dramatically into a swollen red giant over 200 times its present size. Mercury and Venus are swallowed completely by the expanding solar envelope, vaporized inside the stellar plasma furnace. Earth's surface temperature exceeds 2000 degrees Celsius, melting the rocky crust back into a sea of liquid lava. Tidal drag pulls Earth into the outer layers of the red giant sun, where the planet is engulfed and vaporized. Millions of years later, the sun sheds its outer layers as a planetary nebula, leaving behind a cold, dim white dwarf star. Yet the atoms that once built Earth's oceans, mountains, and human bodies will be recycled back into interstellar dust clouds across the Milky Way. Future generations of stars and planets will inherit these cosmic elements, continuing the eternal cycle of galactic creation. Thank you for exploring Earth's 10 billion-year odyssey with us. Farewell, and keep exploring the cosmos.